Hello, welcome again. So, today in organic chemistry, we will be discussing about the periodicity. It is a new unit and it's the first unit which is important for this year's assignment. So, let's discuss about what we will be studying today's lecture. We will be discussing today quantum numbers, and then we discuss about nodes. There are various quantum numbers we will discuss later about principal quantum number, azimuthal quantum number, spin quantum number, etc. And after that nodes, we will be studying about atomic spectra, a little bit about that. And after that we will be discussing modern periodic table. And after that we will be discussing about the effective nuclear charge. Here we will be discussing about the shielding effect, de-shielding effect, etc. After that we will be discussing about the Slater's rule, and after that we will discuss about the atomic radii and then ionization energy. And after that electron gain, enthalpy, and negativity. So let's start with the quantum numbers. Quantum number basically tell us about the state of electron, a total state of electron. There are 4 quantum numbers to explain the complete state of electron. So just like shell, subshell, then orbital, and then the electron. To explain the electron, we will be needing shell, subshell, orbitals, and electrons. So 4 quantum numbers are as. So these are all the quantum numbers. First is principal quantum number, second is azimuthal quantum number, and third is magnetic quantum number, and the fourth is spin quantum number. So the first quantum number, the principal quantum number, it will give information about the shell. Just like this is the nucleus, this is the first shell, this is the second shell, this is the third shell. So n equal to 1, 2, 3. These are the values of n. And the shell principal quantum number is represented by or denoted by n. N is not equal to 0. Okay, this is an important topic of discussion. And if we need to get the energy of the shell, there is a little formula which represent minus 13.6 z square upon n square electron volt. This is the energy of shell, and here this n represent the number of shell present here, and the z is the atomic number. So if we talk about the energy order of these shells, then the E1, which is the E1 which come from the n is equal to 1, the energy is maximum. If we go further from this, from 2 to 3, the energy will decrease. Energy will increase. As we can see from this formula, if you put the values of n, we will get these energies, and and the energy of this, and this, these have the highest energy and these have the low energy. And as we go far from the nucleus, the nucleus energy of shell increases and stability decreases. Higher the energy, least will be the stability. Now let's discuss another formula, which is of radius of orbit. So if we talk about this proton, and there is R1 and another R2, then the Rn equal to 0.529 n square upon में z angstrom. This is the radius of orbit. So let's discuss a question. In this question here, which state of triply ionized Be3 plus 3 has same orbital radius as that of ground state of hydrogen atom? So this question is asking us about the ground state of hydrogen atom, which is similar to which triplet ionization state or the same orbital of same value of radius. So as we know that for hydrogen atom, the n equal to 1 for ground state for hydrogen, and for Be plus 3 Rn is equal to R1, and we know the formula of radius just before that, this formula. So putting the value of all that, we will get the value of n square. N square is 4, so n is equal to 2. Be3 ka R2 is equal to hydrogen R1. They are talking about the orbital radius. This orbital radius Be plus 3 is equal to the same energy level and or the distance is same as the hydrogen R1. And let's go to the second part, the second quantum number, azimuthal quantum number, and it is give information about the subshells. That means the possible value of L, it is denoted by L. We have studied this in our early classes. It is represented by L, and possible values of L is equal to 0 to n minus 1, where n is the number of shell number. Shell number means shell that we studied in the first quantum number. So if n is equal to 3, then the possible L's are n to n minus 1. N means 3 minus 1, which is equal to 2. So L is equal to 0. For 0 it is S, for 1 it is P, for 2 it is D, for 3 it is F, just like S, P, D, F, G, and the values of L is 0, 1, 2, 3, 4. S subshell, P subshell, D subshell. So if we know about the value of if n is equal to 1, let's take an example. If n is equal to 1, then L is equal to n minus 1, which is equal to 0. So we know that in 1s orbital, one only s is possible. These are some important formulas which is used to help us to determine quantum numbers. Just like if we want to know the number of orbital in a subshell, it is equal to 2L plus 1. And if we know the number of electron in a subshell, then if you multiply that with this value with 2, then we will get that the number of orbital in a shell, it is equal to n square. The number of electron in a shell, it is equal to 2 into n square. So these are some formulas which is used. So let's take an example of fifth shell. We want to know how many number of electrons are present here. So to know that, we first need to know the formula. Number of electrons in a subshell, 2 into n square, which is equal to, if we talking about fifth shell, then 2 into 5 square, which is equal to 2 into 25, and it is 50. So there are 50 electrons present. Number of electrons, 50 electrons are present in fifth shell. So let's discuss about the last two quantum numbers, and the third one is magnetic quantum number. Magnetic quantum number, which is represented by ml or simply m. This will tell us about the orientation of orbital. This quantum number discusses about the orientation of orbitals, which means if ml value is equal to minus L to plus L, that means if L is equal to 2, then ml is equal to minus 2 to plus 2. Minus 2, minus 1, 0, plus 1, plus 2. These are the values of atoms, magnetic quantum numbers. And for the last one, the spin quantum number, there are possibly 2 spins are present, which means if this in an box, this is present, which is equal to plus 1 upon 2, and if this is present, which is equal to minus 1 upon 2, plus half and minus half. These are the values of S, and the spin quantum number is represented by S. So to summarize these quantum numbers, we can say that the principal quantum number is tell us about the shell, and n is not equal to 0, and azimuthal quantum number is tell us about the subshell, and L, the values of L can be 0 to n minus 1, and the magnetic quantum number can tell about the orbital number, means ml is equal to minus L to plus L, and the spin quantum number tells us about the spin of electrons, which is equal to plus half, or S is equal to minus half. So this is all the summary which is we discuss in quantum numbers. Before getting into the notes section, we will discuss some of the rules which are present, which will help us in studying more in organic chemistry. Some of them are Aufbau rule, Hund's rule, Hund's rule of maximum multiplicity, and Pauli exclusion principle. These rules and principles we have studied in our early classes. So these 3 rules: Aufbau rule, the low energy subshell will be filled first, according to which the low energy subshell will be filled first. The values of Aufbau rule can be determined with the formula or the rule. We can say that n plus L rule. The low value of n plus L will have low energy and fill first. For example, if a 3D molecule n plus L is equal to 3 plus 2, which is equal to 5, and for 4s, 4 plus 0 is equal to 4. So according to which in our Aufbau rule, if we write an electronic configuration, we will first write 3D before 4s because of the multiplicity, because of the n plus l value. Higher the low value of n plus l will have low energy and fill first. So the value here is low and it is filled first compared to 3D. So first 4s come and then 3D in electronic configuration. And if n plus l value are same, for example, if n plus l value is same, just like for 3p and 4s, the n plus l value is equal to 3 plus 1 equal to 4, and either 4 plus 0 equal to 4. So both the values are same. So if this condition applied, if this condition came, then we prefer the low value of n, just like here 3p will come first. The value of n is considered first, so 3p is more prioritized compared to 4s. So this is told by the Aufbau rule. The next rule is Hund's rule, according to which Hund's rule of maximum multiplicity, according to which pairing of electron in a subshell can't be done until all the orbitals of that subshell is singly occupied. Means we cannot fill the orbitals in this fashion until and unless all the orbitals, means we cannot leave this one, we need to first complete all the half filled and then we put electron here. So this is wrong and this is correct. So this is told by the Hund's rule. So to get the multiplicity, we calculate S, which is summation of all the small s's, 1 upon 2 minus 1 upon 2 for this, or for this plus 1 upon 2, and for this also plus 1 upon 2. So the value is 1 upon 2, which is half. This is total spin, and for that S is equal to 1 upon 2 plus 1 upon 2 plus 1 upon 2. So the value of total spin here is equal to 3 by 2. So the value here is much higher as compared to this. So according to this, this is not preferred, this is preferred. And there is a formula for calculating the spin multiplicity, which is written in the multiplicity, which became the formula is formula of spin multiplicity is equal to 2s plus 1, where this s is total spin. Total spin is this s. So 2 into, we put this value 1 upon 2 plus 1, then we will get 2. And for this case, if we put the spin multiplicity here, 2s plus 1, 2 into 3 upon 2 plus 1, then it is 4. So the value is 4 is much greater than 2. So maximum multiplicity is considered according to Hund's rule. So this is the second rule which we need to know before proceeding ahead. So third rule that come in mind is Pauli exclusion principle. According to which two electron can present in an orbital and all the 4 quantum number of that 2 electron can't be of same spin. The 2 electron in an orbital must have opposite spin. So no two quantum numbers can be same in the same orbital. Means this, let's take an example. Let's put 2 spin just like that, and let's put this. So we know that n is equal to 1 because of the s orbital, n equal to 1, l value for L value it is 0, or for S value it is also plus 1 upon 2, and M value it is also 0. Here also N is equal to 1, L is equal to 0, M is equal to 0, and S is equal to plus 1 upon 2 and minus 1 upon 2. Here plus 1 upon 2, and another for this electron it is also minus plus 1 upon 2. So these two value will be same. So according to Pauli exclusion principle, we cannot put the same quantum numbers, we cannot put this exact same quantum number. There must be some difference in between.